get started here. We'll start with another post by Malware Hunter team. They're always sharing awesome stuff, and this one, uh, some more North Korean stuff. And just wanted to take a look at it because it's it's a fun one. There's a lot already that in the strings itself, there's no obfuscation here, so you can kind of guess what it does. A couple of these we've seen a lot. So like this product version is seen often. Looking at the install log, getting the kernel boot time, and using this user shared directory. It's been seen a lot with North Korean samples, but I thought it was a fun one to look at because the static analysis of this is a little bit strange, and we'll get into that. So we're going to take a look at this sample here. All right, so we're in the main function, and if we look at the symbols, we actually have a lot here that were not stripped. So we can kind of take our pick and go through these. But inside the main function, we're going to look for anything that looks interesting. We saw that there were no strings that were obfuscated, so let's look at where those strings are. And we can already see this first one here, the software product version is passed to this function called execute. We can guess what that does. I assume it executes this. So let's go into this execute function. So right at the top, let's look at this. So we have this address, which is 0 being placed here, and then we have this function being passed the command that was passed in as arg1. So this would be like command to execute. And that's being passed to this function along with whatever this argument is. So let's look at this. And this ends up being the string for R, which if you've looked at samples before, like this, that execute a string, usually that's passed to like a popen function. So we can assume that this will be popen, and this will then be the result. So there's some error handling here, and we can then look at each one of these. So this may result in this popen function. So let's see what happens when we go in here. What we have is a jump to this address, and then this address is going to resolve to this address, and now we're inside of this blob here, which if you've seen this before, you can see that these are going to be calls to imported functions. So we are at this hex ff here, and there's two things that we can do here. Either we can right click and we can make a function at this address, and we can use the default, right? So we're looking at an Intel Mac Mako here. So we can do that, or we can just press P, which is a lot easier. So we're going to press P. And as we assumed, this is popen. So what I do, there's probably a much better way of doing this. Popen is called this function, and I'll just rename this to popen. And now we know that the result of this is going to be here. So popen result. It does some error handling, and it's 0 result. I assume this will be returned. Yeah, we can return this result. So this is going to execute that command that was passed in as the argument. And we can assume this may end up being where the result is passed. So let's look at where execute is called. We have this buffer that was passed in, and then we have this size that was passed in. So let's take a look. How big is that? So 0x14, 20 bytes. And so we have this buffer passed in. So let's see what happens with this buffer. So let's just change this to buffer. And let's change this to be a size of something. And let's continue going through this. So we execute that command, this checks that result. Then this function is called, which checks with an if statement if it's equal to 0, passing in this popen result. So let's see what this is. This is another jump here to another address. We press P, and this is the function feof. So just grab this, go all the way back. This is passed to this function. If it's 0, we do this, another call here to this subroutine using this popen result, checking for 0 and this address. So let's see what this is. Another call to this, press P, fgets. So what they're doing here is they're going to grab the result of the call that was made to that command with popen. So they're going to grab the result of that, and they're going to return that result here. So this is going to be, if I remember correctly, and f gets reads the size and returns a pointer to the string. Okay, so it should return here. It gets the stream and then returns that to the first argument, which is this buffer here. So this is going to be return, let's call it command return. So this buffer that we set up, that was passed in, gets passed into this function. So we got to see what this is. So we go all the way through here, press P. This is stir length, so it's getting the length of this. So let's grab this, copy, go all the way back. One more, and rename this. Len buffer, we get the stirlen of the command plus the length of the buffer. If it's less than the size that was passed in, then we pass in the command return and the buffer to this function. So let's go here, press P, and then we do a stircat. So concatenate the return to the argument that was passed in to that buffer. So that will then prove that that buffer that was passed in arg2 is going to be the return value of the command that's passed in. So stircat, turn that buffer, and then let's see what else happens. I assume this is another popen call. So let's go here, 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 and then p close to close that we called with the popen function call. So here, p close. Okay. So now we have that set up, and I mean, we can kind of make sense of a lot of this. We know that the command that's passed in, so for example, date or this grep install, whatever, is then passed into the popen function. That result is then read, and this command return is put into this buffer that was passed in. So we can assume that this buffer is then used later on. So let's see If we go back to how this is called, we have this buffer, which we can call command buffer. And if we click on this and we look around, it looks like we have more of these buffers for different execute calls. And we go down more, we see that there's an array here that is using these buffers and putting them into this address, and we got to see how this is used. So let's continue with our analysis. Now that we know how this works, let's just move up a little bit. So we know that we're going to have to resolve these imported functions. So let's start with this generate random string. We can assume that this is going to generate a random string of this length and return it to this address, this buffer. So let's see if that's how that works. So this was a size, and this was a buffer. And we then have this being passed to this function, so we got to see what this is. Another one of these, press P, we're going to get time. So let's go back. This is time. And usually this is passed into srand. So P, srand. Let's go back. There's probably a much better automated way of doing this, but it's all right. It's working. So if size is greater than 0, it does this, and it iterates. It adds 1 to I, this index, and it continues this loop using these alphanumeric characters, which then will be returned into the buffer. And we can tell that because this result here is going to be the size that's passed in, and it's going to index on that size of this that was passed in. So putting 0 at the end of this results in the string being null terminated. So we're going to return this. And then we're going to return the string into this buffer, and this is then going to return this count of the size. So let's see what this function does, or what it resolves to. Random. So paste that, or type it. And yeah, so it's just going to do this do while loop, and it's going to grab from here, go back, this random alphanumeric characters, and it's then going to return that. So this will be size. It's going to return that. So this is going to return the random string of whatever size was passed in. So this will be size of string. Actually, let me change this size of string as well. And then it's going to return the random string. So random string would be more appropriate. Okay, going back. And this is then going to be used later. So let's change that. So that is resolved. Let's see what this does. Press P, get hostname. So having seen this function call many times in the past, I know that you pass in 2 arguments. You pass in a buffer where this is going to be returned, and then a size for this buffer. So this is going to end up being the hostname of this endpoint. And I assume this is used later on somewhere, not sure. So continuing from there, actually this might be broken. we have to take a look at that in a bit. So let's continue. We have more calls to execute, which we already saw what they did. This is going to be a sysctl by name call since we're passing in this current boot time, and it returns it. Forgot where this is, man. Sysctl by name. It should return it to, so we have the name that's passed in, and then this. So it will be a second argument that's passed in will be the buffer that this returns this boot time. So let's just confirm that. Having seen this so many times, that's how I know that it's the CTO. So here, and then press P. So sysctl by name. Back, and back. Rename this. Accept. And this will then be, we can actually make this prettier if we want to. So one way of doing that is, since we have the type information here, we can grab this. Oh, this doesn't actually look great, but that's fine. We can just grab this here. Let's see. Yeah, it looks okay. All right. So we can grab this and then change the arguments. So here, boom, press Y, and then add this context. Okay, and then now this will be the return of this. So boot time return. That boot time return is then passed into this function. So what is this? There's P, C time. Go back. And we have this that we zeroed out with this mend set being passed in as this argument. So let's see what this is. And this does other stuff. So this doesn't resolve into what we were seeing before with that jump table for imported functions. This gets the thirlen of the arg2 that's passed in, and then it uses arg1 and arg2, and it passes to this function. And I'm not sure what this does. I assume this has to do with conversion of time. So let's see if we can resolve one of these. So a mem move is used here. Yeah, that's probably what's happening. And what's another call? This passes a lot of arguments. What is this? Resolve that. Grow, buy, and replace. Okay. So let's go back. Accept. And this must be time conversion. So I'm just going to call that time convert, since we're getting the boot time, and then I assume that they're going to convert that time and it might get returned here. And we'll see where else this is used. Okay, so we have another execute, and while true, we're going to do all this stuff. So they're going to be doing a ps aux to get all of the running processes. That's going to be returned here. That's passed in here. So that list of processes is passed here. And we have a couple calls here that we have to resolve. So a little repetitive, but that's what we got to do. So system clock now. C++ stuff. Just gonna try to make these quick. System clock to time. I'm just grabbing the method name, not the other information, to make this not super ugly. And we have that C time, and we are passing in this, and we're doing some more potential conversions here. not going to look into this too much, but let's resolve this and see what. Oh, so exception functions. So maybe some error handling happening here. So we're not going to spend time on that. Let's continue. And we have this execution happening here. And we're setting up this array. So let's see what this is. This RCX, depending on these if statements, sign here or this one. So let's see where this one comes from. Okay, and RCX would then be set up with this one. So I don't see, it looks like there might be something missing here. So see this one. Yep. So it's possible that these are related to these results that come from this execution. Don't know, but we have a couple things here. So this is going to be install results. Let's just name that. So it looks a little prettier here. Buffer one will be hardware model. And this buffer looks like, where does it return from? Oh, it's probably this right here. Potentially, yeah. Okay. So then this then has two arguments that are passed in, but it doesn't seem like there's anything in here. So something is wrong. So let's see what this does. This results in sprintf, which takes in two arguments, and sprintf is a variadic function. So this is going to be the arguments passed in. So we're going to fix that. So this is fprintf. Go back. That's printf. And now let's change the type and add this context. Except, did it do it? It did, but it, oh, here we go. Okay, yeah, so we were missing stuff that we couldn't see. We're gonna ignore these two knobs here, but because it's doing this jump table stuff, it didn't understand what was passed in. We could have looked at the disassembly to see what argument was passed in to the sprintf function for the format string that is then replaced. As you can see, there's a bunch of %s's here that will be replaced by values that were passed on to the stack since this is variadic. So yeah, it's getting this CI and then it's adding strings and then a new line and then more strings and a new line at the end. And we can see if we look over here, things that are passed on to the stack prior to the call to this function right here. We have install result, hardware model. So all these execute related functions are then going to be passed in to this sprintf function. Okay. Now we have, and what is this boot time return? It looks like this is used more than one time. I wonder where this S is. This S ends up being this R15 that's passed in here. So this is going to be, where is that S time convert? So this is going to be boot time converted. And that ends up being here. So boot time. That's fine. Yeah, so that's another thing that's passed in here. And this boot time return looks like it's just a buffer, but it's that space appears to be reused at some point. And we're passing in RBX1. Oh, okay. So in the message that I wrote or whatever and on Twitter, I mentioned that the C2 is passed in as an argument here. And we can see that here, arg1 plus 8, so an offset of whatever was passed into arg1 will then be passed in as the argument to this send request. And we can confirm that that is the C2 in just a moment. So arg1 plus 8, so rbx1, this will be the C2. Okay, so then we have the send request that is passing in this zeroed out address, and this that returns, this is going to be sys printf will then return into the first argument, so this will be sprintf return. Let's fix that. Cool. All right, so it's passed into the send request, and then there's a couple other functions here, process request. So send request, and this is where we can see curl related stuff. So these are for setup. This is going to be the C2, and this is used as the first argument to all of these curl related functions. So that's going to be the easy init. So let's look at that and just resolve that really quickly. Yeah, curl easy init. Okay. And so this is curl handle this type. Oh, this type is curl. Okay, and that handle is passed in. So then we have this R2, which I don't remember exactly what's passed in here. So let's go back. Oh, the data for the send request. So this is some data, and we have the user agent here. We're setting up a write callback. This was this empty buffer, if it was zeroed out, and this must be how it's terminating this curl session. I don't think on this one I have the type information for curl in order to import the header stuff. So let's see, import header file, and then let me get so this one. Okay, let's see if this works. Nope. All right, so there's more stuff that I need to add, which I'm not going to do right now, but you can make it look much cleaner if you end up providing all of these types, these header files, into the import header file, and then it'll resolve these options for you, but I'm not going to do that right now. This will be a curl easy setup call, and then those are going to be the options that are passed in. So this here. Cool. So then I will send out that request, and there's a write callback here to handle that callback. And let's see what this ends up being. It's appending strings after this, so that's interesting. So there's also a call to handle the request. So this was this function, right? So okay, so let's look at that. Since we know that this send request is going to do what it needs to do, and it's going to send that out to the C2, this data that was captured, and there is a process request, which is then going to grab let's see, it gets a random string, gets this, RC3, and yeah, so is going to read that. So let's process this. We have more of these format strings. We can see sprintf here. This is going to be returned, whatever value is written here. We have this write execute call, which I think is where we're going to end. So this write execute will execute. There's a lot of stuff in here that we're not going to focus on. Instead, we're going to go down here. We have this random string that's returned. Sprintf is going to write that to this format, this %s here. So this is going to be path user shared. This is passed into this function, which we have to make sense of unlink. So this is removing that. I guess if it exists first. So unlink, so delete that file. And we have write bytes. So that's going to be, this looks like a file related call. Come in here, P, so that's F open. Okay, let's just grab all this. So this is F open. And change the type. Accept. Okay. And we're opening that up. So this is going to be the file handle. And it will then open this at some point. So with this file handle, it looks like this is a chmod to set the executable bits. So chmod. And stircat, grabbing that, passing it here. So it looks like what was passed in to this function will be put into this same path and then executed. So what it receives from the C2, it's able to write to this file that it creates with this apple open function, and then it executes it using popen. So we're not going to go too much further than this. We can kind of make sense of it now and what it does. A lot of these things have been seen before in DPRK samples, but I thought it was interesting to go through like the resolving of these functions. If you look at this and you see this blob of hex bytes that looks like instructions, you can just press P and you can resolve that, which is really helpful to figure out what these do. All right, well, that's it for this one. Hopefully that's helpful.